Welcome to question number 33 from the June 2015 Geometry Regents exam. Two-part question here, and the first one part is to prove that the triangles AED and CEB are congruent. So I've already started off and written down the statement of what we're given. And our strategy here is I'm going to try to compare these two triangles, find some angles, some side lengths they share in common, and hopefully get to a conclusion that can prove that they're congruent. For me, the most obvious one is that this red angle here and the one opposite it are equal. And that's always going to be the case when you're dealing with two opposite angles. They're always going to be the same. They're going to be congruent. The second thing I noticed that the two triangles share is this distance between AD and the distance between BC are going to be the same. And that's because in a parallelogram, opposite sides will always have the same length. So now we just need one more thing to connect the two, and then we should have enough proof to state that they are congruent. And this comes from alternate interior angles. We do know that AD and BC are parallel because it's a parallelogram. And so if you see this Z pattern here, I'm just going to draw it out in this green marker. Because of this green pattern, this Z pattern, we know that this angle here and this angle here will be the same because they're alternate interior angles. And looking at these two triangles, we can now conclude that they are congruent because we've got an example of the angle side theorem. If we move around this way, and you'll see that over here as well, angle side. All right, so that completes the first part of this question. The second one says to describe a single rigid motion that maps triangle AED onto the triangle CEB. Well, hopefully you can tell by the way that we've just proved this first one that they're congruent, that one is a rotation of the other. For example, let me use a pink marker here. For example, this angle here, when rotated, ends up down here. So this is a rotation. Now, if we want to be as specific as possible, we should say how much of a rotation. And since it's being spun in a half circle, that would be 180-degree rotation. And we should also state around which center. So it's a 180-degree rotation about the vertex point E. And that, of course, is the very center there. So hopefully you're able to visualize that, and that makes sense for you. All right, that's it for this video, and thanks for visiting JD's Regents Preparation.